In this video, we are exploring the third component of our Box-Jenkins model, the I terms. So the I terms. Okay, so when we're using the Box-Jenkins model, we have a very strong assumption, that is, we are assuming our data are stationary. But as we know that the stationary are not guaranteed, as we learn what the stationary means at the beginning of this semester. So stationary means there is no seasonality, there is no trend. Okay. However, if that does not satisfy, we actually cannot directly use our ARIMA model, because that will give the result will be inaccurate. So a stationary time series is the one in which two consecutive value in the time series depend only on the time interval between them and not on time itself. If the data is not stationary, it should be adjusted to correct for the non-stationarity. And so there is like two different methods we can use to converting our stationary data to non-stationary data to stationary data. So one method is called differentiating. So basically we are finding two connected time series data value, and then we find the difference of these two time data. So differencing is usually used to make this correction. So the resulting model is said to be an integrated or differenced model. So therefore that the I in our Box-Jenkins model, the I integrated means we are finding the differences of the two sequential values in your time series data. So by taking this integrated or difference of the time series data, we are able to convert in the non-stationary data to a stationary data. Okay, again, the stationarity is a very important check before you can before you can say I'm just using ARIMA model without including I. So the good thing is, as we're using our forecast X model, so it will automatically detecting should we need this integrated term in the model. Okay, but here you need to understand when we need to introduce in this I term, integrated term, it is when the data is not stationary. Let's look at example together. How do you know the data is not stationary? So we follow the same idea, finding the track based on the ACF or PACF diagram. So in chapter 3, we learned that we can use ACF or diagram to identify if our data are stationary or whether the data has a trend. So if the ACF showing our those spikes are slowly dying down, so very slowly dying down, so that indicating our data have trend. That also means our data is not stationary. Remember, if the data has trend or have seasonality, so we consider data is not stationary. So therefore, in this situation, if our original data showing the pattern, when we look at ACF diagram, showing this slowly dying down on the top of the diagram, we need to finding the value for I, which is integrated or differencing our data. Okay, so after we take the first difference, so some students say, wait, I still not understand what this difference means. So let me show you what does that mean. So let's see this time series data, Y, taking the value 2, 6, 11, 15, 16, right? So they are all by time, at the time 1, so this is a time index. 1, 2, 3, 4, 5. So when we talk about take the first differencing, that means we are find the difference between two sequential values. So we call the delta Y. So that is my new time series. What I will do is I will use next time period minus previous period. 6 minus 2, I got 4. 11 minus 6, got the 5. 15 minus 11, got the 4. 16 minus 15, I got 1. So after you differencing your data, you definitely will miss one observation. Depends on if it's the first differencing, that means you only find difference between two sequential values. So if it's the two differencing, so usually that's an advanced model. So what you're gonna do is after you take the So after you take the difference between the first and the second observation, so you take another difference. So this is called the first difference. See? So if you look at the second differencing, that means after you receive the first differencing and you further to find difference between based on the first differencing. So you are using the 5 minus 4 equal to 1, and then 4 minus 5 equal to -1, 1 minus 4 equal to -3. So in the real world, most of the empirical work I saw is only take one first differencing, and you are able to converting your non-stationary data to stationary data. Okay, so basically the example I'm showing you here is that this is my original data, okay, and then I see they are non-stationary, right? So they are non-stationary. What I did is using this first differencing, use the first differencing, and I'm able to get in the new data, and I'm fitting the data fitting to my model again. So this is a new ACF diagram. As you can see, the new ACF diagram no longer show me has a trend because this is not slowing down. So after first spike, the data already shrinked. And then the second is I'm using the ACF1 because we see, ACF also showing us we need to use MA1 because there was one spike. And then I also tried AR1, but you definitely can try AR3 as well. As we can see here, we had the 3 spikes. And then so since we definitely can try AR3 as well to capture to AR3, I1, MA1 to capturing all the pattern we see from ACF and PACF. But as you can see, after we're taking the first differencing, my data becomes stationary. Okay, so now I want to mention on the left hand side, as you can see, there is expression here. The model we used to model this time series is ARIMA111. So what does that mean? So usually we call it ARIMA, P, D, and Q. Okay, so for the 3 parameters inside this expression, so the P is corresponding to, how many AR turn you wanted. And the D is corresponding to how many integrated term you wanted. And the Q is related to how many MA term you wanted. So in this case means for the AR, we use 1 term, AR1. And the I is corresponding to 1. That means that we only had the first differentiating. And MA corresponding to 1 as well. So that means for the MA term, we only had MA1. Okay, so that is how you should read in the numbers within this expression. So 3 numbers. Okay, so in the next video, we're going to look at, as I said, we are using Forecast X. So they pretty much optimizing the algorithm to help us identify the best P, D, and Q values. But since we are learning this class, not